All right, AP Stat students. This is a short video going over the first 10 multiple choice questions on this practice AP exam. Some of these I'm going to give answers to, some of them I'm not, just because I want you thinking through it, but this is a good resource if you need a little bit of help in this review. So here we go. I'm going to do this in OneNote. So of the following dot plots, which represents the set of data that has the greatest standard deviation? Remember, standard deviation measures how spread out something is. So if I want the greatest standard deviation, you want most spread out. That means the opposite of spread out would be very centric. So I think once you interpret this as least centric, this should pop out. One of these definitely has very little in the center, least centric and most spread, so I'm not going to answer that one. A random sample of 374 United States pennies was collected, and the age of each penny was determined. According to the box plot below, what was the approximate IQR? Should be pretty basic. Remember, this part right here would be quartile 3. The bar here would be the median. And this would be quartile 1. If you're talking about IQR, think about quartile 3 minus quartile 1. Once you follow these to the side, you should get a pretty good idea. I'm not going to answer that. The histogram above shows the number of minutes needed by 45 students to finish playing a computer game. Which of the following statements is correct? This should be pretty easy here. Just remember the skew is in the tail. A bank surveyed all 60 of its employees to determine the proportion who participate in volunteer activities, which is true. The bank should not use the data because this is an observational study. First of all, observational studies can be useful. You could get data from this, so I'm going to eliminate this. And I don't think that was actually an observational study. Or perhaps it could be, but it's definitely not an experiment. The bank can use the results of this survey to prove that working for the bank causes employees to participate in volunteer activities. A word here that really kind of kills this one is causes. This would not be able to prove causation. The bank did not select a random sample of employees, so the survey will not provide the bank with useful information. I would also eliminate this one. It didn't select random employees, but you could still have useful information from this. The bank would have to use the survey data to construct a confidence interval in order to estimate the proportion of employees who participate in volunteer activities. I would also get rid of this one because it asked all 60 employees. So you don't have a sample here. It's pretty obvious once you actually get all the way down to E. The bank does not need to use an inference procedure like confidence interval or hypothesis test to determine the proportion of employees who participate in volunteer activities because the survey was a census. It says all 60, that's a census. This kind of jumps out at you quick, as long as you read all of those. This histogram below displays the frequencies of waiting times in minutes for 175 patients. Clearly, this is a skew right diagram. Skews in the tail. So one thing you have to remember, obviously right here would be a mode. But when you have something that's skewed right, you'd have a median off the mode. And remember, the mean is always in the tail. That should make this one relatively easy. Data was collected on the amount in dollars that individual customers spent on dinner at an Italian restaurant. The quartiles are given. Remember, that means this somehow will look like this, where quartile 1, median is quartile 2, and quartile 3. So That means, let's interpret that. That means 50% of the data is in the quartiles, 50% of the data is above median, 50% is below the median. Also, that means 25% is above quartile 3, 25% is below quartile 1. So, at least half of the customers spent less than or equal to $44.27, and at least half spent greater. Well, that works because it's not at least, it's exactly half. And then just to keep going, 75% of the customers spent between 36 or quartile 1 and 58.97. 75 would be wrong. This has to be exactly 50% between the two quartiles. Keep going through all of those. They're all wrong. This one gave people trouble. You're used to normal distribution problems, but this one really relies on z-scores. So the weight of an adult male grizzly bear living in the wild of the continental U.S. is approximately normally distributed with a mean of 500 pounds. I'm not going to use X-bar. Mean of the males, 500 pounds. Standard deviation of the males, 50. The weight of an adult female grizzly bear says about 300 pounds and a standard deviation of 40. Approximately what would be the weight of a female grizzly bear with the same standardized score, z-score, as a male with 530. So start by finding a z-score. So all z-scores are just x minus the mean over standard deviation. Well, in this case, you know what, I'm interchangeably using mu and x-bar. But starting with a male grizzly bear with a weight of 530, so 530 minus the mean of the males is 500 over standard deviation, 50. So our z-score for males would be 0.6, or 30 over 50, which is 0.6. So you want to use the same z-score. So the z-score for female would be the same. So 0.6, and we want to know the weight of the female. We know on average they're 300 and their standard deviation is 40. Solve it. Hopefully you can, once it's set up, you can solve that on your own. A company sells concrete batches in 5 cubic yards. The probability distribution of X, the number of cubic yards sold in a single order for concrete from this company is shown below. So the expected value of the probability of distribution of the number of cubic yards X is 1925, and the standard deviation is 576. There's a fixed cost to deliver the concrete. The profit Y in dollars for a particular order can be described by that standard deviation of Y. So this one makes you remember that for transformations, standard deviation is spread and not affected by adding or subtracting a constant. So that means I really don't care about that minus 100 there. So if I'm looking at the standard deviation of X being 576 times 75, the dilation or multiplying does actually affect it. So 75 times 576, you can find that answer. I'm running out of time on this video. I know I said it would be roughly the first 10. So the number 9 and 10 will just be on the next video.